Okay, welcome back. So we have started discussing about these two types of errors that we have. The first one, we call it false positive, to mean that your program wrongly says that it is a correct output while it is not. Okay, that's what we call is false positive. And this is type 1 error, or we call it type 1 error. What we call false negative is the pattern or the string is correct output, but your program wrongly says that it is not. Wrongly, it says that it is negative. So we call it a type 2 error. So we have to focus on this one. For instance, for false positive, it means, let's say we are looking for the word the, okay, the. We want to find the word the in a text. But if your program says this is true and this is true, just because it has the within it, it is true. We call all these three outputs, we call them false positives, because we are looking for the string the, but as you can see, each of them has an additional character with them. But your program was not able to say that this is wrong. So we call them false positives. So for instance, again, in here, we are looking for the word the. But what if inside the document, what if we have the with uppercase? And what if it is missed? If it is missed, we call this one false negative, because we are looking for the word the, which is the. And if it misses this one, then we say this is a false negative, or we call it type 2 error. And these are, this is very important in computational linguistics. So let's see more this in a form of a mathematical representation. So we call this one a confusion matrix, or we call it an evaluation matrix that we have to compare what we have got using the program and what is actually in the real world or in the ground truth. So the one that we have in here represents the actual class. So the actual class means the real world. Okay, it represents the real world, the fact. And this one is, it's a predicted class, which means this is what your program, says. So for instance, A and B, this is an output from your program. And your program says this is positive. And the one that we have in here are those that are left out. Are those that are left out by your program, because your program assumes that these are negative values. These are not correct results. B and D are results that are discarded by your program, whereas A and C are instances that your program says are correct outputs. Okay, so P for a predicted class is what your program says are correct, and N are the instances that your program says this is wrong, or they are not supposed to be included in the result flow. You'll find it in here. So this is the first one. The other thing that we have, okay, the other thing that we have is the real world. So in the real world, what do we have? The real world means this actual class. So in the real world, or if you see the ground truths, these are the values that are actually positive. A and B are the ones that are actually positive in the real world. And C and D are those that are negative in the real world. So in the actual class, C and D are negative and A and B are positive. Now, whenever you write a program, you want to compare the similarity between the real world and your program. And it's common that your program will make a mistake. And the mistake are of two types. One of the mistake is your program might wrongly include an incorrect result, or your program might wrongly exclude a correct result. And those places where there is an error are the two diagonals, here and here. These are the two places that errors are occurring. Now, if you see the first one, your first one, in the real world, in the actual world, it is not correct, or it's not a correct result. In the real world, in the actual class, it is no, but your program says it is positive. In the real world, it's negative, but your program wrongly says that it is positive. The other one is, in the real world, it is positive. As you can see, in the actual class, it is positive. In the actual class, it's positive. Here, but your program says it is negative. So these are the two types of errors that we want to avoid. So what we call type 2 error is, in the actual world, it is positive, but your program says it's negative. That's why we call it false negative. Your program, wrongly say this is negative. And this one, we call it false positive because it is actually negative in the real world, but your program says that it is positive. So whenever you want to minimize errors, or whenever you want to increase the accuracy, then what you have to do is try to reduce these two values, okay? If you decrease this value, or if you reduce A and C, if you reduce A and B, C and B, what does it mean? You reduce false negative, you reduce false positive. So what does it mean? You are going to have more accurate results, but it's not a simple task. So once you have this, once you have calculated or counted A, B, C, and D, then you can come up with these 4 different measures of evaluation or metrics of evaluation. You can calculate the accuracy of your program, you can calculate the precision of your program, and you can calculate the recall from your program. I believe you remember what precision and recall are from your information retrieval course, either at undergraduate level or even at a graduate level. Precision and recall are the most common evaluation metrics that we use in information retrieval. Now, what does it mean? Let's first see what a precision is. Precision means how pure is the output, okay? Precision is concerned about how pure is the output. It's not concerned about what is left off, or it's not concerned about what is not shown. Precision is concerned about what has been shown, and from that one, how many of them are correct. So what is shown to the user is A and C. What the user can see is only A and C by your program, because what the user sees is what has been predicted as positive by your program. The user display is the one that are assumed to be positive by your program. So predicted class like positive display. Now from what has been displayed, how many of them are accurate? Mind you, false negative. True positive one. So precision is A, which is a true positive, divided by A plus C. Because this is what has been displayed. This is what has been displayed, by your program. So let's see, from what has been displayed, how many of them are accurate? So A is the accurate one, and what has been displayed is A and C. So this is what we call as precision. Recall is not concerned about purity, okay? Precision is concerned about purity. Purity ማለት ከወጣ ውስጥ ምን ያህሉ correct ነው ማለት ነው. Which means if you have many incorrect results, ምን ይሆናል? If you have many incorrect results, what's going to happen? The value of C would be high, right? If you have many incorrect results. ስለዚህ ምን ይሆናል? The precision value is going to be small. If C is big, if the value of C is big, then it means recall is going to, precision is going to decrease. So that's what we mean by precision. Recall is concerned about getting all correct results. It doesn't matter how many incorrect results are also displayed. It is concerned about how many of the correct results have been included in the output. So what are the correct results that we expect to see? The correct result that we expect to see is A and B. This is what we expect. The correct result that we expect to see would be A and B, because in the actual class, the positive classes are A and B. Okay? Systemula, or in the actual, in the real world, what we call positive or correct is A and B. Now from A and B, how many of them are included in the result? It is A. Result is the predicted class, or by your program, what you get is a value of A. So what we call recall is A divided by A plus B. This is what we call is a recall of a system. ይሄ ይሆናል ማለት ነው። It is concerned about getting all correct result. It doesn't matter how many negative results that you get, but as long as you have more positive results in your program, then we say the recall is high. The last matrix that we have is what we call an accuracy. So in accuracy, we are concerned about, reducing false positive and false negatives, right? So what we call correct results are these two. These two are the correct result. True positive means your program and the real world agreed as being a valid result. Whereas true negative means your program as well as the real world agreed that these instances are incorrect. በዚህ ላይ ነው የተስማሙ። ስለዚህ a plus d እንልና is going to be divided by the total number of cases that you have. A plus b plus c plus d, and this is what we call is the accuracy of your system. So please try to understand this confusion matrix, and whenever you do analysis, this is what you are supposed to do. Now let me give you a very simple case in here. Okay, what if this is what I have in a text. እንደዚህ ብለን እንጠይቅና let's say this is an input text that we have, and you have written a program, and the program is identify let's say numbers እንበለውና ከዛ let's say we want to identify a number, and what your program has given you is 24 and 1 ብቻ ቢሰጠን ማለት ነው። Okay, this is output that is given to you, and we call this one ይሄ ማለት የሲስተሙ output ስለሆነ as a positive. This is what we call is p የምንለው ይሄ ነው by the system. But in addition to this one, let's say your program also gave you, let's say, first, and your program also first and አልሰጠንም. Let's say 2 and 4ንም አብሮ ሰጥቶናል ማለት ነው። So in this case, this is a prediction by the system. Now from here, we know that A ማለት true positive የሆኑት ማን ናቸው? 24 and 1. This is A. What about B? B የምንለው ደግሞ is 2 and 4, because this is not a digit actually. So B is having a value of 1, whereas A is having a value of 2. በዚህ መሰረት ማለት ነው። Now in the real system, false positive የምንለው በዚህ case false positive የምንለው is this one. Sorry, this is C. False positive የምንለው ይሄንን ነው, because your predicted class ምን ብሏል? false positive እና true positive እና false positive ይይዛል. So these two are true positive and this one is false positive. So A ማለት 2 ነው, C ማለት 1 ነው ማለት ነው. Now let's go to the other side. So actually what do we expect as an output? እኛ የምንጠብቀው 24ን እንጠብቃለን፣ 1ን እንጠብቃለን፣ 2ን እንጠብቃለን፣ 4ን እንጠብቃለን፣ 1ን እንጠብቃለን. These are the numbers that we expect. Okay? ይሄ ማለት these are the actual positives that we are expecting. Now in this case, C ማለት false positiveዎቹ እነማን ናቸው? ያልተገኙት ኦኬ፣ እዚህ ጋር እንመለስና ያልተገኙት ማለት ናቸው? ሲ ማለት ነው። ያልተገኙት እነማን ናቸው? 24 እና 1 ተገኝተዋል፣ 2 አልተገኘም። ኦኬ 2 4 and 1. these are sorry, these are D ናቸው እነዚህ። these are D. B ናቸው, sorry, B. These are false negatives. They are supposed to be found as numbers, but they were not found by your program. Okay, ስለዚህ A ን አግኝተናል ላይ፣ C ን አግኝተናል፣ then B ን አግኝተናል። D ደግሞ true negative የምንላቸው እነማን ናቸው? true negative ማለት ነምበር ያልሆኑት በሙሉ ማለት ነው። So what does it mean? The word or the string st, then number, then is, then the word which is, okay, እነዚህ በሙሉ we call them ampersand, no, yeah, and together, then as, then value. እነዚህም በሙሉ ምን እንላቸዋለን? We call them, these are true negatives ናቸው. Okay, true negative means those that are not numbers ማለት ነው, because if we are looking for numbers, then non-numbers are true negatives ናቸው ማለት ነው. So if you find the value of A and the value of C in here, you see, the value of A is 24 and 1, which means they are two in number, ሁለት ናቸው. Then what we call C is false positive now, because the output 2 and 4 and አንድ ላይ ስለሰጠን, this is false positive. Then these are true negatives and these are false negatives ናቸው, መቅረት የሌለባቸው የነበሩ ማለት ነው, because this is what we actually are expecting. Then you can calculate the accuracy, because output ይሄንን ነው የሰጠን አይደል? Now what is the precision? What is the precision? Anyone? What is the precision value? እዚህ ጋር እንምጣና, precision means A over A plus C. So what is the value of A? 2. What is A plus C? እዚህ ጋር 2 አለን፣ እዚህ ጋር እንዳለን 3 ማለት ነው. Which means from the 3 outputs that are given to me, 2 of them are accurate ማለት ነው. That's what we call is a precision. What about the recall? Recalls. Recall ምንድን ነው ብለናል? A over A plus B. So what is the value of A? 2. What is the value of B? 2 plus እንልና, what is the value of B? 1, 2, 3 ናቸው, 3. So it means actually we are expecting 1, 2, 3, 4, 5. አያችሁ? የምንጠብቀው ምንድን ነበር? The correct result should have been these 5 numbers. So ሁለቱም ብንደምራቸው 5 ነው. ከ5 we got only 2 of them, because in the result what we get is 24 and only 1. But we were expecting 24, 1, 2, 4, and another 1. So in this case, we say the recall is 2 over 5. The precision is 2 over 3, to mean that from the 3 outputs, only 2 of them are correct. The recall is 2 over 5, which means from the 5 that we are expecting to see, we have seen only 2 of them. Then if you go to the recall, I mean the accuracy ላይ ደግሞ ብንሄድ ምንድን ነው የሚሆነው? A plus D, A is 2 plus D is የታለ? No, yeah, D is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ነው. Okay, divided by the total number ማለት ነው, which means 10 plus 2 plus 1 plus 3 በእነዚህ ሁሉ ይካፈላል ማለት ነው. Because 2 is the true positives, 10 are true negatives. True positive የምንላቸው እነዚህ ናቸው, true negative የምንላቸው ደግሞ እነዚህ ናቸው. So true positive plus true negative divided by the total number of elements. The total number of, እዚህ ጋር 2 አለን, እዚህ ጋር 1 አለን, እዚህ ጋር 10 አለን, እዚህ ጋር 3 አለን, 10, 2, 1, 3 ማለት ነው. So this is how we are going to calculate the precision and the recall as well as the accuracy of your model. But to do that, make sure to first have this confusion matrix, because this confusion matrix will tell you how much confused your program is. And the most important element that we want to focus is on true positive and true negative, because this is on which your program and the real world agreed. ሁለቱ are the one where your program and the real world agreed. And most of the time when you do analysis, you want to reduce these two values. You want to reduce false negatives. If you reduce false negative, what does it mean? True results are extracted by your program. We want to also reduce false positive, which means those values or those instances that are assumed to be positive, which actually they are not, should be removed if you reduce false positive. So most of the time, whenever you want to improve your program, whether it's regular expression or any other, if you want to increase your precision increase ማድረግ ከፈለጋችሁ, what do you do? To increase precision, what do you do? Yeshuas?
Yes.
To increase precision, what do you need to do?
reduce false positive.
እቺን ማለት ነው ፎልስ ፖዚቲቭን ካሳነሳችኋት ምን ሆነ ኤ እና ኤ እኩል መሆን ይጀምራሉ አይደል ያን ጊዜ ወደ 100% እንመጣለን ማለት ነው so reduce the value of c reduce false positive ማለት ነው you see if you reduce false positive then your precision is going to increase what if you want to increase recall ለመጨመርስ minimize false negativeዎችን አሳንሷቸው ማለት ነው ያን ጊዜ these two values are going to be close to 1 the value of b 1 ቢሆን በቃ close to 1 ይሆናል ማለት ነው ምክንያቱም ይሄ 10 ቢሆን ይሄኛውም 10 ነው ስለዚህ 10 ሲካፈል 11 is very close to 1 being 0 ካደረጋችሁትስ it's 100% which means all correct results have been identified so if you want to increase recall or increase your coverage then minimize false negatives false negative ማለት the one that are assumed to be incorrect by your program should be minimized okay so saying this much about the evaluation metrics then let's move to some computational linguistic tasks one of the computational linguistic tasks that we have is sentence segmentation in a running text if you have a large text from that large text you are required to identify a sentence mind you identifying a sentence is language dependent because the one that you use for English and the one that you use for Amharic or for Tigrinya or for Walaita or any other language is quite different, okay? So what you have to do is, first you have to understand how the language demarcates one sentence from the other. So for instance, in almost all languages, exclamation mark and question mark they are not ambiguous because we don't use them for anything else. A question mark and exclamation mark, almost in every language, we use them as indicators or markers of an end of a sentence. But what about period, for example, for English language? This is a very ambiguous word because you can have it as a sentence boundary, that's true, but you can also have it for abbreviations like incorporated or doctor lamalet or engineer lamalet, we use a dot. So it's not the end of a sentence, malet, no, we use it for shortening. Or we can also use it for number to identify a digit, a number with a digit, then we use also a period. So it's very difficult, as you can see, even here, it is really difficult to say, whenever you find a period, to say, to make a decision whether it's the end of a sentence or is it a number or an abbreviation. So it's a challenge. So what you have to do is you have to come up with a classifier. And the task of the classifier is look for a period in a running text, look for a period and make a decision. You have to make a decision whether it is an end of a sentence or not end of a sentence. So it's a challenge, ማለት ነው ለምሳሌ ይሄንን ለማወቅ ምን ታደርጋላችሁ ከዶቱ በፊት ምን አለ upper case ምናምን ካለው then you might say this is not an end of a sentence rather than it's an abbreviation or before and after the dot if you have a number then you might say it's not an end of a sentence so what does it mean you need to write a regular expression that looks into something that appears before or after it ስለዚህ periodን ካገኘ በኋላ ምን እንለዋለን look for the thing that appears after it and before it ለምሳሌ ያኛው ዲጂት ከሆነ ትላላችሁ ከፊት ያለው ወይም ከኋላ ያለው ዲጂት ከሆነ then it's not an end of a sentence if it is a digit then it might be the end of the sentence by the way it's quite difficult እንደዚህ አይነት sentence ብታገኙስ okay the GPA of the student sorry is 4 እንደዚህ አድርጌ ባቆምስ is it the end of a sentence or is it part of the number
Sentence.
Yeah?
Sentence. It is the end of the sentence.
እንደዚህ ቢሆንስ
No, it's not the end of the sentence. It's about expressing the GPA of students.
Exactly. I don't know. So you see, sometimes it's part of the number, sometimes it is the end of the sentence. So it is really ambiguous, to deal with such kind of things in linguistics or in a language. So sometimes you can use a handwritten rule, mind you, it means a regular expression, or you can come up with a machine learning algorithm to build this one. So you have to build a kind of a decision tree, and a decision tree is from your machine learning course, it is an if then else statement. If this happens, this, otherwise it is this one again. You have to come up with a decision tree structure. So the challenge that we face in here is, what is a feature that you are going to look for? ዝም ብሎ dot ማየት ነው? Or are you going to say what appears before or after the dot, or in what kind of context the period or the dot is used, is quite challenging. So setting up a structure is often too hard to do by hand. So most of the time people try to look for a machine learning algorithm from a training corpus to decide whether it is an end of a sentence or not. So for instance, from this text, how many words do you see? How many words do you see from this text? Huh?
Words.
How many words? Mabrat? 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 Mabrat?
16 words.
16. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 16 كده መጣሽ? እሺ ይሄንን ለምን ሁለት ብለሽ ቆጠርሽው?
Because of the space.
It's because of the space.
Yeah.
So እንደዚህ ብጽፍስ? How many words do you have in here?
5.
አዲስ አበባ ግን አንድ ቃል አይደለም? የአንድ ቦታ መጥቀሻ አይደለም? መግለጫ አይደለም?
No.
Okay. So it means you have to pay attention to this, okay? You have to pay attention to this. Whenever you do text analysis, you have to really understand the language that you are working on. And we have two type of information in here. When it comes to tokenization, the task of tokenization, we have what we call a type and a token. A type means it is an element of a vocabulary, which means it is distinct ማለት ነው. Okay? Whereas a token is an instance of a type. So it means type is unique. አንዴ ነው occur የሚያደርገው. Whereas a token is the occurrence of a type ማለት ነው. So if you do that, in the first case, when it comes to the tokens, it can be 15 or 14. ለምንድን ነው 15 or 14 የምንለው? It can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15 ልንል እንችላለን. But if you consider San Francisco, since it's a single name for a place, you can say it is 14. It depends on how you analyze it. But when it comes to a type, we can say, let's clean this one. When it comes to a type, it can be 13, 12, or 11. Why? Because a type is a unique vocabulary entry. So in this case, if you look into these words, okay, the word they and the word there, one is, the derivation of the other. And if you see the word there, it appears twice. So you don't have to count it twice. And if you see the word end, again, it appears twice. So you don't have to count it twice, malatni, in this case. So when it comes to the other one, San Francisco, you can count it as 1 or 2. It depends, okay? So that's why we say it's either 13, 12, or 11 ያለው በዛ ምክንያት ነው። San Francisco እንደ ሁለት ከቆጠር ነው, then it can go to 13. So they and there are a product of the other. And is written twice, there is written twice, so you don't have to count it twice. So ምን እንላለን? This is 1, 2, 3, 4, 5, San Francisco እንደ አንድ, 6, 7, 8, 9, 10, ዘን አንደግምም, 11 and then አንደግምም 12 ይሆናል ማለት ነው። So it can be 12. ሳን ፍራንሲስኮን እንደ ሁለት ከቆጠር ነው 13 ሆነ ማለት ነው። ዜር እና ዘይን አይ ደሪቬሽኑን አንፈልግም ካለን then it's going to be 11 ይሆናል ማለት ነው if we count them as one ማለት ነው። So this is how you should recognize tokenization. Tokenization is about identifying words, but whenever you identify a word, it's not a simple task. You should care about tokens and type. Token column, since we are concerned about instances, then any number of times occur in Biaraga, we are going to count it in such a way. So as we said, tokenization has a language issue because sometimes the Chinese and the Japanese might use a writing with no space between the words. So it's going to be difficult to identify where the word boundary is found. ለምሳሌ እንደዚህ ብለው ሊጽፉት ይችላሉ, but actually the word boundaries are in here. እነዚህ ናቸው word boundaries. But knowing that word boundary has its own linguistic requirement. So you have to understand how things are written using Chinese and Japanese scripts to say that this is a word and this is not a word. ለማለት you need to do that. Okay? And that's why we say it is a language issue. Let's consider an Amharic text again. Amharic text, we know that recently, because of the keyboard, we are no more using ሁለት ነጥብ, but if you see old writing, you'll find this. እንደዚህ አይነት ነገር ታገኛላችሁ አይደለ? ዛሬ ቤቴ እንደዚህ አይነት ነገር ታገኛላችሁ። So in this case, we know that ሁለት ነጥብ is the sentence, I mean the word delimiter. እንዲህም ብናረገው ችግር አይፈጥርብንም ማለት ነው. If we write it in such a way, even without a space, we know that the setup of the keyboard, allows us to use a space instead of ሁለት ነጥብ or ነቁጥ for word delimiter. But if you write it in such a way, this is also perfect. So in this case, to split or to tokenize a sentence, then you have to use ሁለት ነጥብ as a delimiter, and that's perfectly fine. That's why we say tokenization is a language-dependent task. It depends on how the language is written. So further complication might also appear in the language or in the scripting method. And sometimes you might have different ways of writing a date. For instance, people might write it in such a way, or in Amharic, you can write it, the preposition and the conjugate can be combined or separated. Whether ቤቱና ብለን ልንጽፍ እንችላለን as one, whether ቤቱና, where there is a space between whether እና ቤቱና, or we can say whether ቤቱ እና ልንል እንችላለን, or we can separate each of them. So as you can see, there are different standards of writing, and normalizing that is very important for the task of tokenization. So in tokenization, the important question that you need to ask is this one. Tokenization is about splitting a running text into words ማለት ነው. Tokens are, instance of the type, instance of the vocabulary that we want to identify. So an important question to ask is which element is required from the text, okay? Because we know that whenever you do tokenization, you don't need everything. For instance, you might not want the punctuations, you might not want the numbers, you might not want the special characters, okay? Maybe you are interested about only some type of words. So the first thing that you have to answer is what is the relevant part that is required. The next thing that you have to work on is how to separate it from the rest of the elements. ለምሳሌ እዚህ ላይ if you are interested about numbers, then how are you going to identify numbers from this, and from this? Mind you, በሃይፈንም ሊሆን ይችላል. So the next thing that you need to answer is how to separate from the other part. Then the other thing is how you have to deal with irregularities. Mind you, language is filled with irregularities. So how are you going to deal with that irregularity? ለምሳሌ እዚህ ላይ we said a date አለ ብለናል አይደል እዚህ ጋር. What if you have such kind of a date which is not regular? እንደዚህ ተጽፎ ብታገኙት the 2nd of January 16 ብለን ብንጽፍስ? Okay, so it means it's not in line with the other standards that we have. But mind you, this means 02/01/2016. but this is an irregular pattern. So how are you going to deal with that irregularity is another task, another question that you have to answer. Then for what kind of application do you need the text? Are you looking, or are you extracting the text for speech purpose? Are you looking for it for language modeling, for a translation? So for what kind of purpose or for what kind of application it's required for is important for the task of tokenization. And what is a possible output? What is the output? Is it at a word level, at a sentence level, at a phrase level? And finally, it means you have to answer whether it's a word, a character, a punctuation, a number, or what is the output that we expect. So you have to answer these 5 questions whenever you do tokenization, okay? The other thing that we do is normalization. We have discussed about this one, like converting it to the same standard. Like if you see the Amharic word hager, 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 even though we know that the most frequently used are these 2, but you might find it with other forms as well in the text, because you don't know, you don't control the author. So in this case, converting all this to one standard format, be it this ha or this ha, whichever that you think is appropriate, is a task of normalization. Have a look at the English word USA. One with a dot and the other without a dot, and the other one is only US. All of them are referring to the United States of America. So unless and otherwise you convert it to the same standard, then we know that your language model or your program will misunderstand or misrepresent this. So sometimes we want to create equivalent items by deleting period in the term whenever it is used with abbreviation. Or you can also use asymmetric expansion method. Whenever you find such kind of abbreviations, why don't you expand it? Okay, so whenever you expand it, it will match with the other form. Whether you use it with a dot or without dot, expand kadaragno, then they are going to be of the same type. So such kind of formats, like whenever you enter the word window, you can have window as well as windows with uppercase as well, with uppercase with S. So making such kind of standardization is a task of normalization, and it's very important. Normalization also works for uppercase, okay? Normalize scenario, maybe changing the uppercase to lowercase or lowercase to uppercase is one of the things that we do. And that's what we call is case folding in Nalwalan. And these are some of the things that you can see in here. You can use substitution. As you can see, you can substitute all this with the letter ha in this text. Make sure to attempt this one. And it's very important in natural language processing, okay? Okay, that's good for now. The last thing that we have is case folding. We already have discussed about this one. To change the uppercase to lowercase or lowercase to uppercase based on the application is what we do. So next time, we are going to move into a new topic, which is stemming, okay?